Right now, engineers are landing roles at top companies by building production-ready AI agents. At Interview Kickstart, we've helped over 25,000 engineers transform their careers. And if there's one skill that tech job postings are demanding today, it's AI. In the next 40 minutes, we'll build a sales analysis tool that any product or service company could use. One agent pulls live sales data, another uncovers hidden trends, and a third generates your full weekly business report, all in minutes. Imagine replacing your data, analytics, and strategy teams with intelligent agents that deliver cost savings, faster decisions, and deeper insights. Master this skill, and you'll have a standout project ready for your next AI interview. If you're still using old Fang Prep guides, you're already losing ground. The rules have changed, and this free AI playbook shows you what's really being tested in modern Fang interviews. Insider strategies, hidden evaluation matrix, a 90-day mastery plan, the exact playbook successful candidates are using right now. Everyone's grabbing it. Don't be the one left behind. Link in description.
Okay, let's dive into the code and we will see how a multi-agentic workflow can be executed using Autogen framework. So we'll begin by installing some libraries. Since we are using Autogen, we'll install Autogen Chat, Autogen extensions to connect to OpenAI models, OpenAI libraries. So we are using Kaggle Hub here. So we'll download our data set from Kaggle Hub. So let's import Kaggle Hub. Also, we'll do some data manipulations and transformations using pandas. Let's also have some libraries for plotting if and when needed. And that is all. So in the first section of the code, we are going to download the data. Now the data set is downloaded from Kaggle Hub and all the relevant files are stored locally for further analysis. We'll begin with previewing the list of the files that were downloaded and the sample of main sales data. This will help us verify that the data structure in the content before starting the processing of the data. And we'll then process and normalize the data, which will include currency fields, transformations to numeric types, dates from strings to date format, data merging across product and region, and filling any missing region gaps, and even a normalized sales table, which is created for analysis and then further loaded into a SQLite data. Now, this kind of data processing and preparation would usually be a part or should have been like pre-done by your team before even starting a agentic work. But in case it is not, this highlights the need for preparing the data before having your agentic systems work on it. And if a strong foundational data is very important because whatever the difficulties or whatever the quality issues are with the data, that will highlight, even they may be amplified when in your agentic workflow, they start showing up. Okay, so it's very important to have a clean, structured data before even beginning the agentic work. So let's just execute first section where we'll install this library. And this is a Jupyter Notebooks. We are connected to a Python virtual environment here. So let's just execute this. I already have installed, so this should finish up in few seconds. Next, we will download the data set from Kaggle. And again, Kaggle is a data repository hub and it has a lot of data sets which you can download and do your analysis on top of it. And we are downloading here the AdventureWorks data set, which is a data set about sales of company, fictional company known as AdventureWorks. We have tables here like sales, products, regions. So let's just download this data set. So it'll take a couple of minutes for installation and then the next cell will run. Okay, this is done. Then we are downloading the data set here and data set is now downloaded and it is now loaded up. Now let's start with listing all of the files in the data set directory. And let's also read one of the data set in this. Okay, so these data sets are downloaded as a CSV, just separated by tabs. So this we have identified through some pre-analysis. And let us try to list all of the files that have here and then see one of the. So we have a files about salesperson region, reseller, targets, product, and sales.csv. And looking at sales.csv, we see data like sales order number, order date, product key, reseller key, employee key, sales territory key, quantity, unit price, sales, and cost. Now, let us look at the primary data sets that we'll be dealing with in this, which is sales data set, product data set, and region data set. So let's do a quick listing. So we already see the sales column has sales order number, order key, etc. Then the product data has 397 rows with 8 columns and the region table has 10 rows with 4 columns. Okay. So this is a pre-analysis of the data. Then we have here defined methods to clean the currency. So we are replacing the dollars here and replacing the commas with the empty list so that we have numeric numbers finally, right, for the currency. As you have seen here, you see the unit price in dollar 28.84. We are essentially going to replace it 28.84. And if the value is like 4049.98, then we will replace the dollar and the comma, and we will essentially going to get a float number 4049.98. So that's the clean currency method. Next is the parsing date, where we are parsing the string date into a datetime format. Next, we have a clean sales data. So this method will basically call the parse date and the clean currency date to clean the order date, unit price, and sales. Then we will merge the product and the region data. So we will merge the sales data with the product data and the sales with product data with the region data so that we have one combined view. And now we can fill the gaps in this region data with one of the NA, APAC, or EMEA regions. And once we have a normalized data set, we will create a final data frame, which we will load it into the SQL DB. So let's just run this cell. So this kind of data preparation is essential and would be handled by either your data engineers or it may be you who is doing that. But identifying what data you need and how do you prepare that data for the agent is a crucial part to building such an agentic workflow, especially which relies heavily on the data. So let it finish in a while. By the time it does that, let me also explain you the next cell, which is about we create a new sales CV and we connect to it. And then we are creating the sales table using the sales normalized sales data that we had created in the previous cell. We are loading it up into the SQL DB. And we will verify that database. After creating it, we will test it with some queries like total number of rows, maybe even show a sample of rows from that. Once that is done, this will also okay. We see normalized data set where we have ID, date, product, region, unit sold, and unit price. Those are the things that we needed. So we did only with that. Okay. Again, we see the same thing. We have total number of 57,851 rows. Okay. Now comes the exciting part. We are going to use Autogen to implement our agentic workflow here. So we are implementing a BI reporting system using Autogen. And we will have following agents in the Autogen framework. One, we will have a data agent. Now, this data agent will execute the SQL queries on our sales database. Then we would have analytics agent, which would process the data and generate insights. Then we would have a writer agent, which would create a formatted report with visualization. And lastly, we have our orchestrator, which will manage the entire workflow between these agents. So let us begin by importing some Autogen libraries here. So most importantly, we first need to import a OpenAI AI chat completion client, which will basically create OpenAI model client through which our agents would interact with the model. Now let us create first object, which will be used by all of our agents to interact with the model. And we could have a different model client for different agents, but since we are doing in like a prototype stage here, we can use the same one for all of the agents. Now, this is how we can control what model is get used for which agent. And for this case, we are using same for all, but if you can use different ones, then you would have basically more control over which model should be used for which age. Next up here, we are choosing GPT-5 and we are using OpenAI API key to to connect to the database. So I have already saved my OpenAI API key in this environment file. So let us now create this model client, which will be used by our agents on the line. So our OpenAI Autogen agent's configuration has been complete. Now let's come to the exciting part where we create a data agent. Now, since our data agent needs to connect to the SQL database, we would need a tool to connect to the SQL database. So here we are creating a SQL execution function. This is a regular Python function which will connect to the database and execute the queries. So this execute SQL function takes in a query, which is a string, and there is a description that this should be a SQL query to execute on the CSV method. Next, it also takes a code, which is again a description of what the query is trying to achieve. And this could be empty as well. And lastly, it would output the query result with success status, data, and metadata. So we would try to execute the query. We'd connect to the database and we would basically use the query which is passed in the parameter. We would use the connection and we would execute the query and get a result. Then we'll convert that result into the data frame. And we'll finally result if it is able to execute the query, then we will return true. And we will also return the data frame and the result along with it. And we'll also add query and the goal which was initially passed to it just to keep track of it. And then we will also pass the length of the results. And in the exception, if it fails, then we would say success fails and we would also pass the errors. So this kind of structured development is essential and it will help you with the debugging as well. Now let us wrap this function in a function tool. Now this function tool it's provided by Autogen. So this basically takes in a function and a description of the function, which is like, execute the SQL queries on the sales database. It would take that up and make a tool out of it. And this tool could then be used by our AutoGen agents to execute the queries. So next, we are here defining the AutoGen agent. So we are using the assistant agent here. We give it a name, data agent. We give it the model client, which we created in the previous cell. This is the brain of the model brain of the agent that we discussed initially. We could give it a list of tools. So here we only need a SQL tool, but essentially you could give a list of tools as well. And now this is the most important part where you are defining what the agent can do. So let me expand this a bit and you can see. So you are a data analyst with the direct access to the sales SQL tool. So we are describing the role of the agent here. Then we'll define its responsibilities and reasoning. So we are asking it to generate and execute SQL queries to extract the relevant data for business analysis. You can use the provided SQL tool to run the queries and return results in a structured format. And always explain what your query you are trying to achieve before executing it. And focus on accuracy, clarity, and actionable data extraction. So this is the reasoning that we are defining for our agent. Then we are also giving the sales database table schema. Now, this is important because the agent does not know what the table columns are, what they even mean. Now, here the names are self-explanatory, but in your enterprise environment, the names would not even be self-explanatory. So, you need to pass in that context to the model, like what are the columns, what are the tables, what each of the columns in the table mean, how do they relate to each other, that relation among multiple tables if you have. All of that need to be passed into the data agent as a context. So, as a suggestion, maybe you can prepare all of that in a JSON and then pass that JSON in this system message. And basically, we are defining that when this agent receives a prompt, it will analyze the business goal and generate the appropriate SQL query, and then it will execute the query using the SQL tool. We are also saying that you should reflect on the tool use so that we can see the tool usage in the logs, and we are also saying that you should stream the output rather than just waiting for the completion and then returning the output. The model is here streaming the output. So now we would test our model. We'll console the stream that the model is going to generate in the logs, and we'll see how the model actually thinks, how it connects to the tool, how it executes the function in the tool, and how it returns the result, and then use that result to produce the. So let's do a very simple query here that let's get me the count of all of the rows in the sales table. Now let's see it in action. So first, this is the user message that we started with. Get counts of all the rows from the table. Now this is where you see the model thinking. So you see the data agent thought process here. So it says, I will run a simple SQL query to count the total number of rows in the sales table. Another SQL goal is to return a single value, which is the total number of rows in the sales table. Now it will execute the query. So for executing the query, it is going to use the tool. So here you see the tool execution event, where you see the function call being made, the arguments that were being passed, which is the query, which is like select count star as total rows from sales, which is a reasonable right query there. The goal, which is the count the total number of rows in the sales table, and the method execute SQL query. So here the model has come up with the right selection of tool. Here it has only one tool, but if it had multiple tools, it would have come up with the right selection of tool based on the tool descriptions that we have given in the function tool. After selecting the right tool, it figured out the right parameters to pass to it. So in this case, based on the function parameters description defined here, that's essentially being wrapped in the function tool, the model is able to understand what are the parameters that I need to pass. What exactly do I need to pass to the method? And it's generating that correct parameters for it. And then ultimately the AutoGen framework is making the call to the function using the parameters that the model has come up with. And so here it is executing the SQL query. This is the SQL query it is executing, and this is the goal. So this is what we have outputted in the logs, that executing SQL query, next line, code. This is the one you should print. Okay, so this is part of our function. Function has already been called. So now at this point of time, this is the function execution result which has come up. And in this, we see the content which says success true data as the data frame, total rows 5781, data frame, the exact data frame that was returned from the SQL query, the query itself, which is your select count star as total rows from sales, the goal, which is the total number of rows in the sales data, the row number, which is 1, and the method, which was being called execute SQL query, call ID is error equal to false. So this shows us the function execution result. And finally, we see the data agent summarizing the response. So I ran a query to count all the rows in the sales table. SQL executed. This is the SQL that I executed, and this is the result. So here you see the tool use pattern in action that we talked about. where the model is using the connected tool, the tool which has had access to, figure out the right tool, figure out the right parameters to call for the tool, get the result, summarize the result, and present it to the user. So this is your tool use pattern in action, which is all facilitated by the simple Autogen framework definition. So Autogen is allowing us to just define what the tools are, what the system message is, and then it is handling all of that orchestration behind the scene to get to call the right tool, to get the right data, etc. So that's the power of Autogen framework in action. Now let's make it a little more complicated. Let's move to the analytics agent here. So the analytics agent is a business analytics agent with access to the sales data. Its workflow is when given a business goal, first it should come up with a clear, concise English question or a request that it should then ultimately pass to the data agent to obtain the necessary data. So it might come up with a question like, what is the total sales by month between this and this? So given a goal, it will come up with this English question that it can ask to the data agent. So then send the English question to the data agent, which will translate it into a SQL query, execute and return the results. So we define the role for the agent. We are now defining the reasoning for the agent. Next, analyze the return result and compute one to two key metrics, KPIs relevant to the business goal, which was initially given to the model. Detect any major trends and anomalies and give a clear actionable recommendation. So this is where we are defining the reasoning for the model, how the model should reason. Next, we have sales table columns. So again, we are defining what the columns are included in the table that the model can use. So this analytics agent also need to know what columns are available so that it can come up with the right set of questions which it can ask to the data agent. And we are also defining that for each analysis, it should focus on most relevant KPIs, things like total sales, growth rate, etc. We are also asking it to identify the most significant trend or anomaly. And ultimately, we are asking it to summarize the findings and the recommendations concisely. And same here, same to the previous model, we are also reflecting on tool use. We are also going to stream the model flag output. Next, we are defining a team of agents here. So we created an array of agents, which is your analytics agent and the data agent. Then we created a team. So how it works in Autogen is that you can create a group message or group team of multiple agents, and then you can define a termination condition when that group should stop chattering. So in this, we are defining that the maximum message of termination, when the termination of 6 messages has been received, we should terminate the group chat. Since it's a round robin group chat, these two agents will go back and forth against each other, asking the questions to each other to get towards the goal. Now, this is your multi-agent workflow in action. This is where we see two agents communicating autonomously. The agents will work autonomously as we saw in how we are scaling the AI systems. We talked about 4 things, right? Autonomous scaling. We also talked autonomous execution. We talked about independent execution. We talked about shared context. We talked about horizontal scaling. Now, is all of this is facilitated by the Autogen framework here. So Autogen is handling autonomous communication among the agents. It is providing them a shared context for the execution, and it is allowing each agent to execute independent of each other. So once we have defined the team, we are resetting the goal for any new task, and then we are running the team. So now this team will run the stream. So run stream method basically means that as soon as the team start executing, it will start logging the output, which we will capture to the console. So now we are giving it a broader goal. We are giving this team a broader goal that analyze the sales trend between this and this date and come up with the 3 business insights. So this is a broader goal than the previous one, which was given for the data agent, which was much more specific in terms of what data we needed. But here, since analysis agent is coming up with the plan of what are the questions that I need to ask, and then it is using the data agent to get the response and then summarizing it, we are giving it a higher goal. So this is your planning pattern in action, where the analysis is going to plan what subtask it needs to do. Then it uses the data agent to execute those subtasks, get the result, and summarize the output. All of that being handled here through Autogen. So let me run it and you will see the outputs coming up. So this is the first user message that we started with, which is analyzing sales trend between this and this date and coming up with 3 business insights. Now let finish for a while and then I'll explain the thought process that's going around it. And mind you, all of this is happening autonomously. These agents are communicating among each other autonomously to complete the goal that it was initially given. So that's your agentic workflow in action, where it's planning, using tools to execute, getting the results, summarizing, etc. Okay, let's start with this while it's running. So here we see the analytics agent thought process. So it will ask like, what are the daily, this is the question, English data question that it is sending to the data. What are the daily total sales? Like total sales, like sum of units sold into unit price and daily total units sold for each date between the May of month. And this also provide me total sales and total units sold for the entire period broken by product and the region. It has come up with a very broad task, right? I want these things. So it is saying that before I request the data, quick confirmations, I'll compute KPIs, total sales for this month, average data sales, etc. Identify the single most important trend or anomaly, and top product are this, and provide three actionable business insights and action. Shall I run this query and fetch the results now? So this is where you could have, right now we don't have it, but you could technically have a human in the loop here, where the agent or the workflow would stop at this point of time, get human confirmation on this thing that, okay, this is the query that I've come up with, this is the plan, you like it or not, and then human could say, okay, let's go ahead, then the workflow would continue. But since we don't have it, the agent would just go ahead here. So now the data agent says, I'll run a set of SQL queries to extract the requested data and KPIs. Specifically, I'm looking up for the daily totals, which is the daily total sales and daily total units sold for each day. This, which is the first task. Next, it comes with the second subtask, which is total by product, which is total sales and unit sold for the entire product group by product. And then we have total by regions, where we have total sales and unit sold for the entire period grouped by region. And then we are also getting overall KPIs and half month totals, things like total sales, total units, first half, sales, second half sales, to compute week over week of growth as well. And then we are also getting peak and trough days, where the single highest day is sales and lowest day sales in this period. So all of this tasks it has come up with based on the broad question that it was sent to. So now the data agent has planned out these are the multiple set of questions that I need to answer, and for them I need to run the SQL queries. So it will run these queries now in action. So you would see that it has come up with the queries on its own, that this is the query that I want to do, and this is the goal that compute the total sales and units for the period. This is the next query it has come up with, and find the single most highest day in the sale. And it has come up with single date, select date, etc. and the single most lowest date, etc. So all of these CP queries that it has come up with, and so and then it will use the function call tool and the function executor to execute the queries, and the function execution tool is where you would see the output in your response. So now it says that I ran the following queries to extract the requested data, which is the daily total sales for each date. This purpose was to get day by day revenue, and units to see the daily trends and spot spikes and dips. The next one was totals by a product, which was the purpose was to identify the top product by revenue and volume for the month. The next it trains identifying top performing regions by per month. Then it also ran compute total sales units, compared months to halves, find the single highest day sales and find the lowest sales. And then it summarized, okay, this is the total sales I've come up with, total units sold, first month average, average daily, second half average, peak day, peak lowest day was this, notable daily patterns that the strongest sales day was between this, and mid month it was mid month dip was between this, and the top product by sales is this, share of total monthly sales is this, and total sales by region, top sales by region is this, and shares of total monthly sales is this. So as you see, all of this the data agent has come up with on its own, where it has kind of summarizing the data before sharing it with the analytics agent. So it has come up with a long list of the results based on the multiple SQL queries that it's executing. So it also came up with actionable insights for the recommendation, which it will then pass on to the analytics agent. Now here, we didn't define the data agent to not come up with the insights, so hence it did, but you could essentially also restrict the data agent to just get the data itself. We didn't ask it to, so that's why it's also coming up with the suggested next analysis as well. Now again here, if you would have a human in the loop, you could basically say, yes, let's run this analysis too, and then it would run it. So this is where the data agent asked the question, and it got the response from the analytics agent asked the questions, and it got the response from the data agent. And it's describing its process, it's describing the key API, the single most significant trend anomalies, the concise actionable insights and recommendations that it has come up with, a suggested next analysis like root cause join, sales with promotions, inventory levels, incident logs for this, spike attribution, like type peak days to campaign IDs and discount codes. And for the analysis for the data which we don't have here, but it is suggesting that if you had, I can do it. And again, it is asking like what kind of next analysis you want me to do. So it is then coming up with, okay, let's say let's do the root cause investigation for the May 16 and 19, and this will give us the highest diagnostic. It is again So the analytics agent say, okay, these are the things that we should do. So data agent is not chatting. So these agents are chatting back and forth. That okay, let's look at the root cause analysis. So initially, analytics agent gave it a broader goal, which is executed, gave the result. Then analytics agent say, okay, maybe we should do some more analysis. So then it asks data agent to do then data agent says, okay, I can run this analysis. Then it is running that analysis and it will do that. And now the root cause analysis, please perform. It says, okay, which one would we want me to run? So it's coming up with the some recommendations here, what analysis it can run, like the queries it can run. Then it says, okay, I can run. Please perform the root cause analysis for this date, and then it is coming up with that. Either the proportional source data exists, then do this analysis. All of this is they are doing it back and forth on their own. And here the termination is ending because we asked it to terminate after 6 months. But other than that, you would also see how else we can define the termination. So here you see multiple agents back and forth in communication, autonomous execution, shared context to all of that inbuilt in autogen and executing independently of each other. Okay, let's move on to the writer agent. So for writer agent, we first define an agent response identical class object like HTML and thought, which is the object, which is the output that we expect from the writer agent to do. So coming up with the writer agent again, we define the name, we define the model client, we define a system message. That the role, we're starting with the role that you are a reporting specialist. Your job is to generate a well-formatted, visually appealing HTML report. Then we are defining it the instructions that you would receive structured data, KPIs, and insights from the analytics agent. Create a clear professional HTML report that includes all of these things. Use a semantic HTML structure, which would use the L5 structure. Add minimal inline CSS for readability. Always return the complete HTML as a string in the HTML field of the agent response. Ensure that the report is accessible, readable, and suitable for business presentation. And when the HTML report is complete, append the phrase report complete at the end. And I'll show you why we need it. But when the report complete at the end of thought, feed to signal the orchestrator that you can terminate now. And we are even giving it example structure that, okay, this is the structure of the report that I'm expecting. Again, we'll ask it to, when the report is finished, we should print the report complete to thoughts. And we are also defining the output format using the agent response subject class previously defined. So let's create this writer agent. And now finally, we have a BI reporting orchestrator. This is the class where we are going to initialize our set our model client, data agent, analytics agent, and writer agent. Now this orchestrator as a method run, which would get a goal. Okay, so the goal could be something like generate a weekly sales data. Then it would also get analysis period, basically the period of analysis we wanted to do the analysis on, and the maximum messages. I'll show you why we need it. So this is the run method, and we are creating a team of agents again here. And this time we have writer agent as well in the team. The termination condition is defined using an OR condition. So we have a max message termination, which is equal to the 25 messages, and a text message termination report complete. So we need both here. And the reason being, we want the agents to do the analysis back and forth until they are satisfied. And once they are, the writer agent would prepare a final report and print the report complete. So ideally, the report complete would be the condition where the group chat should end. But here, it could also be possible that the agents keep going back and forth, but they never come up with the final analysis. That's where we need a max message termination as well, so that we don't end up in an endless loop of agents communicating back and forth with each other. So we define it with the OR condition, whichever is met first, that will end the group communication. And again, we are setting up a round robin group chat. We have agents here defined, analytics, data, and writer agent. We have a termination condition being defined. And we also define the custom message type for the writer agent. Now, this is the task that for the team that we are defining, that you will be given a goal, analyze the sales data from this analysis period. And now we are defining a reasoning that first the analytics agent should generate English data questions and request data from data agent. Then data agent should translate those questions to SQL, execute, and return results. Lastly, analytics agent should analyze the data, compute KPIs, identify trends or anomalies, and give recommendations. Lastly, a writer agent should compile all of these findings into a markdown report with a visualization and ensure that the report is clear, concise, and actionable. And again, we are defining the sales table schema so that the team is aware of what is the schema of the table, based on which it could define the task for the analytics agent. And then by starting the English data question, you are passing it to the data agent. Okay. We are defining the reasoning for the team in this. Now let's start the team. So we have defined the team task. Now let us run the team. Now here you would see a different pattern of running the team where I'm running the team and for each of the message, I'm printing the message. And then I'm also defining if the message of instance agent response, which is the final response that writer agent will produce, we would capture the HTML from it and we would save it in the report HTML and which we would essentially save. We'll get that report HTML and we will save it into a HTML file on the local server. Okay. And if there is any problem with the execution, then we will log a exception. Now we could also stream the responses here. You can uncomment these two lines of the code and comment the rest of the lines of the code to stream how the responses look like. But it would very similarly, it would look like how we saw for the analytics and the data agent. Hence, I'm skipping the part here and I'll just run the orchestration. So let us run the cell. Let us run the cell. Now this cell is where we'll start the orchestrator.run method, giving a goal of generating weekly sales report. Once the execution is complete, we would basically displaying the content of the HTML inline. So let it execute. It would take 2 to 3 minutes to execute. So just to summarize what we have built here, we have built complete BI reporting system using autonomous autogen agents. We firstly had a data agent which uses autogen function tool for SQL execution with retry logic inbuilt. Then we had analytics agent which would compute KPIs, detect anomalies, generate insights, etc. Then we had a writer agent which would create formatted markdown HTML report along with some visual look. And finally, to top it all, we had our orchestrator, which is managing this workflow using the Autogen T with integrated SQL tools for the data engine. So this is how the technical architecture looks like. We have Autogen agents. Those agents connect to SQL tools using function tool, and through that we are connecting to the SQL database. And BI reporting orchestrator has three agents: one data agent, which is connecting using SQL tools to the database, then analytics agent, which is computing KPIs, and lastly, we had a writer agent, which is generating the final report that we will see soon. Okay. So I'm also sharing few examples here, how you can run the standard workflow, how you can use the enhanced Autogen workflow here. Right now we are not using it. And you can even directly call the tool usage to validate whether your SQL database connection is working or not. So with that, it's almost like wait 1 or 2 minutes and that should be completing the workflow. Okay. So we have the communication done. We see the messages for each of the agents communication here. We have an analytics agent. And if you would basically see towards the left, you would see the thought process behind it as well. And you see the analytics agent, data agent, all that communicating. And then finally the writer agent communicating preparing the report. So that report is saved in this folder. You can see it here coming up. And we can also preview the report here. We see executive summary that this report summarizes the sales activity for this period and this month was done with the episodic high volume days and a concentrated set of product of regions. Total monthly revenue was this and 10,129 units were sold. It has come up with a visual representation of the key KPIs and trends as well. That the total sales in the month was this, sold units was this, average weekly sales was this, and average daily sales was this. Average selling price was this. Then it has come up with the weekly totals as well. So weekly, what is the total of the sales? What is the total number of units being sold? It has also come up with the top product contributors. Like what is the top products? What are their sales and what are their units being done? And again, we say that, this top 5 product contribution, the products combined for the 20% of the monthly sales. Then we also come up with a regional breakdown, that what is the breakdown by each of the region in this. And finally, we didn't ask it to produce the JPEGs, but it could actually also produce the JPEGs that attach it. We also see the daily spikes and anomalies. So it's doing the trend analysis and anomaly detection as well for us, where we say that, okay, on this date, we see the highest single day total. Let us investigate what happened here, like maybe some promotion or some other thing, but this could be a data issue also. Like, we should analyze this further. So then it is coming up with the, recommendations of the next set of actions that you should drill immediately this anomaly, which is, we have a high day production and you can also run this transaction level export for this. You can also confirm drivers like promotion code, large corporate, B2B order, etc. You should also confirm inventory and fulfillment for the late May, that check the stock outs or shipping delays. You should leverage the top products and regions, and you should implement daily anomaly monitoring. So alert when daily sales is greater than 2 times the daily average. You should have a smooth operational reporting, which is using 7-day rolling metrics, etc. And suggested next queries as well. So you see an entire end-to-end BI report has come up. We have come up with through the use of 3 agents that we had, which is analytics agent, data agent, and the writer agent. This is a very powerful construct using Autogen to create a multi-agentic workflow without doing a lot of handling in terms of code, of retrying, of how do the asynchronous communication happen, how does the shared context happen, and all. Now let's go back to the slide. So with that, we wrap up the session. Thank you for being here. I really appreciate you taking this time today. If you're looking out for a Gen AI or agentic AI related courses, check out the IQ webinar for Sing. Thank you everyone. This has been great. Myself Pratik Singhal signing off. Have a good day.
If you like this video, you will love what I have to say next. The 14-week Agentic AI program at Interview Kickstart helps engineers build real, career-ready skills. You'll work on 2 live projects with FANG instructors and leave with portfolio work that actually makes a difference in hiring. Over 20,000 tech professionals have already trained with Interview Kickstart, with many moving into roles paying $300,000 plus. Want to learn more? Join the free upcoming webinar, ask questions, meet the instructors, and see if it's a fit. Not ready yet? No problem. Start with the AI agent building videos here on the YouTube channel. We recommend this one. Either way, the key is to just get started.